All right, so this is question 19 from the 2022 exam 2. A box is formed with a rectangular sheet of cardboard which has a width of A units and a length of B units by cutting out the squares. So in order to do this question, what we need to first do is draw out this scenario. And this scenario looks like this. You've got a square rectangular sheet of cardboard. And with this cardboard, we've cut out an X, 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 and we've got a length and a width that's respectively, in this case, A units and B units. Now, when we fold this up along these perforated lines here, you'll see that it makes a height and into a 3D shape. So we're going to make this into a box. Okay, and with this particular box, the height will be of X, and we will have a different width and a length as well. In this case, we've got two X's, so one X here and one X here, which means we get A minus 2X, and the width or the depth is going to be B minus 2X. All right, now this one is asking for the maximum volume. So if we're looking for the volume, we need to use the formula volume is equal to length times width times height. So that's going to be this dimension multiplied by A minus 2X multiplied by B minus 2X. Okay, now from here, we've got our volume formula, and we want to find the maximum volume, which means that we need to find when is dV dx, excuse me, dV dx is equal to 0. And once we find out what dV dx is equal to 0, we can use our CAS to work that out. And using your CAS, you'll get an answer that's A plus B plus minus the square root of A squared minus AB plus B squared over 6. Now we've got to be careful with this because when we look at our answers, a lot of students will jump to B as the alternative answer here. However, when we actually sketch our graph of V, what we recognize is this is a particular cubic, and this cubic has, I don't know if this is the exact shape or not, it's going to pass through 0, that's for sure. So we don't know if that's the case, but with this particular cubic, we have, in fact, a stationary point here and a stationary point here. But we've got a plus and a minus component with this as well. This plus component relates to this stationary point, and the negative component relates to this stationary point. So you need to make sure that the answer is in fact D, and we take into account it's negative because we want to find that positive maximum value.